Hi there, in this video I'm going to show you how to transform expressions of the type. So if we're given an expression of this type, a hyperbolic cos kx plus or minus b hyperbolic sine kx, I'm going to show you how to transform such an expression into the form r hyperbolic cos kx plus or minus alpha, okay, and a, b as well as k, these are all constants, so a, b and k are all constants, and r, the value that we're going to calculate here, is going to be a value greater than 0, and alpha here will be in the form lnp, okay, so it's going to be in the form of a natural logarithm. And these values, I'll show you how to calculate these. So where a, b and k, these are constants, okay, and r is a value greater than 0, and alpha, this alpha here, is going to be in terms of lnp, so it's going to be in the form of a natural logarithm. Okay, so let me show you how this is done. So let me take some examples. So example number 1, so let's get our ruler and red pen ready. So in example number 1, let's express 13 hyperbolic cos x plus 5 hyperbolic sine x in the form r hyperbolic cos x plus alpha. So let me show you how to do this example. Okay, so let me show you the steps involved. So let me break down the method in terms of steps. So in step number 1, okay, so we need to write 13 hyperbolic cos x plus 5 hyperbolic sine x in the form of r hyperbolic cos x plus alpha. Okay, so now we need to use the identity hyperbolic cos a plus b in order to rewrite that term, hyperbolic cos x plus alpha. Okay, so let's do that. So let me use a red pen. So we're going to use the identity hyperbolic cos a plus b to rewrite hyperbolic x plus alpha. Let me remind you of that identity. So let me take this red pen again. So as a side note, hyperbolic cos a plus b has the form hyperbolic cos a hyperbolic cos b plus hyperbolic sine a hyperbolic sine b. Okay, so that is the identity. So if we make the comparison here, RA is x and RB is alpha. So RA here is x, B here is alpha. So if we do the replacement of A and B into our identity, we're going to have, so on the left hand side, 13 hyperbolic cos x plus 5 hyperbolic sine x, and that is equal to r. And what I normally do is, like in the trigonometric version, I write r, I open up a square bracket, okay, and then I use the identity and replace a and b into the identity within that square bracket. So a is x, b is alpha. When I do the replacement, we're going to have hyperbolic cos a, which is x, hyperbolic cos b, which is alpha, plus hyperbolic sine a being x, hyperbolic sine b being alpha. Okay, so that is step number 1. Okay, in step number 2, we're going to equate the coefficients of hyperbolic cos and hyperbolic sine on both sides. Okay, so let me write that down first of all. So by equating coefficients, okay, so we're going to equate the coefficients of hyperbolic cos, because that appears first on the left hand side, so hyperbolic cos x, and hyperbolic sine x, okay, on both sides. So let me start off with hyperbolic cos x, as that appears firstly on the left hand side. So let me take a red pen, let me highlight the terms. So I have a hyperbolic cos x term on the left, here's my hyperbolic cos x term on the right, and when I equate the coefficients, okay, I have 13, the term in front of hyperbolic cos on the left, so 13, and that is equal to, okay, on the right hand side you have r hyperbolic cos alpha, so r hyperbolic cos alpha, let me call that equation number 1, okay. And if I do the same with hyperbolic sine x, so if I equate the coefficients of hyperbolic sine x on both sides, let me take this green pen, let's highlight them. So here's my hyperbolic sine x term on the left, here's my hyperbolic sine x term on the right, okay. Coefficient of hyperbolic sine x on the left hand side is 5. Okay, so write down the 5. Okay, you don't need to take into account the signs because the signs should be the same on both sides. Okay, so supposing if we had a minus here and a minus here, when you equate the coefficients you don't need to write minus 5 is equal to minus r hyperbolic sine alpha, for example. Okay, so you don't need to include that minus sign because that will eventually cancel out. So remember, these two signs should be the same, okay, on both sides. So on the right hand side, when I look at the coefficient of hyperbolic sine x, we have r hyperbolic sine alpha, so r hyperbolic sine alpha, let me call that equation 2. Okay, now in step number 3, means calculating alpha. So let me show you how to calculate alpha. So that takes us to step number 3. To work out alpha, we divide equation 2 by equation 1. So we need to divide the hyperbolic sine equation by the hyperbolic cos equation, because hyperbolic sine over hyperbolic cos will give you hyperbolic tan. Okay, so by dividing equation 2 by 1, so divide in the order hyperbolic sine over hyperbolic cos. So left hand side, it will give us 5 over 13 when we divide. Right hand side we'll get r hyperbolic sine alpha over r hyperbolic cos alpha. Okay, in this step the r's should cancel always, and hyperbolic sine over hyperbolic cos will give you hyperbolic tan. So that's what we'll have here. Okay, now to get alpha, so hyperbolic tan alpha equals 5 over 13, but alpha will be the inverse hyperbolic tan of 5 over 13. Okay, so let's continue on the reverse. Okay, let's have a quick look at that previous step. So alpha is the inverse hyperbolic tan of 5 over 13. To work out this, okay, you can use your calculator, and remember, so let me take my calculator. So remember, there is a HYP button in the calculator, which when you press it, I hope you can see that, it will give you a library of hyperbolic functions, so you can use the calculator to work out the inverse hyperbolic tan of 5 over 13, but you could also use the definition and write alpha in terms of ln using the definition of inverse hyperbolic tan of x. Okay, so let me show you how to use the definition. So remember the definition of the inverse hyperbolic tan of x. It had the definition of 1 over 2 ln 1 plus x over 1 minus x. So that was the definition. Okay, remember that definition is true when the modulus of x is less than 1. Okay, so I hope you can see that. So if I replace the x's in my definition by 5 over 13, let's see what we have. So we're going to have alpha is equal to 1 over 2 ln 1 plus x is 5 over 13 over 1 minus x is 5 over 13. Okay, so if we continue to simplify, we'll get 1 over 2 ln 1 plus 5 over 13, so that is 18 over 13 over 1 minus 5 over 13, that is 8 over 13. Okay, you can simplify this, so the 13s will cancel. So if I continue along the line, I'll have half ln 18 over 8 simplifies to 9 over 4. Okay, and you can also simplify this further, because half ln 9 over 4, okay, you could write that as ln 9 over 4 to the power of half. Okay, so let me continue here. Alpha will be ln 9 over 4 to the power of half, as you know, is the same as 9 to the half. So 9 to the half is 3 over 4 to the power of half, which is 2. So that is the value of alpha. Alpha in terms of ln is ln 3 over 2. Okay, so that was step number 3, calculating alpha. Okay, in step number 4, let me show you how to calculate r. Now, to work out r, what we need to do is, let's go back to the equations. First we square, so we square these equations, and then we subtract. So I'll show you the order of the subtraction later, and I'll also explain why we square, why we subtract. Okay, so step number 4, let's square the equations. So by squaring equations 1 and 2, and we're going to square on both sides. So if we square equation 1 on both sides, 13 squared is 169. That is equal to r squared hyperbolic cos squared alpha. So let's write that down. So 13 squared 169, that is r squared hyperbolic cos squared alpha. Let me call that equation 3. And if I do the same operation to equation 2, so if I square both sides, 5 squared being 25, that is equal to r squared hyperbolic sine squared alpha. So 5 squared 25, that is r squared hyperbolic sine squared alpha. Let's call that equation 4. Okay, so step number 4 is to square your equations 1 and 2 on both sides. And in step number 5, we need to calculate equation 3 minus equation 4. So you need to calculate and do it in the order hyperbolic cos squared minus hyperbolic sine squared. Okay, so do your subtraction in that order, hyperbolic cos squared minus hyperbolic sine squared. The reason being is there is an identity, hyperbolic cos squared minus hyperbolic sine squared gives you 1. Okay, so in step number 5, equation 3 minus equation 4, So if we do 3 minus 4, on the left hand side, 169 minus 25 is 144. That is equal to, on the right hand side, r squared, let me take that as a common factor, hyperbolic cos squared alpha minus hyperbolic sine squared alpha. And remember, this is an identity, hyperbolic cos squared minus hyperbolic sine squared alpha equates to 1. So r squared is therefore 144. R is going to be the root of 144, which is 12. So bearing in mind r is a value greater than 0. Okay, so that is step number 5. Calculate the hyperbolic cos squared minus the hyperbolic sine squared equation. So do it in that particular order. So in this case, it's going to be equation 3 minus equation 4. So let me replace the r and the alpha finally into this initial equation. So in this case, we're going to have 13 hyperbolic cos x plus 5 hyperbolic sine x. So 13 hyperbolic cos x plus 5 hyperbolic sine x, and that is the same as the r value is 12. So r is 12 hyperbolic cos x plus, and the alpha value we worked out in terms of ln, that was ln 3/2. So that's the same as r being 12 hyperbolic cos x plus alpha value ln 3/2. Okay, so that completes this example, and here are the steps. So I've wrote down the method in the form of steps, so there are 5 steps in total. And yeah, so this is the method in order to do an example like this. Now I'm going to continue this example by finding the range of this expression, okay, and I'm also going to show you how to sketch an expression of this type. So I'm going to continue with this example here. So let's call this example 1a, okay, and let me continue in a fresh piece of paper. So this page is done. So in part B, state the range of y is equal to 13 hyperbolic cos x plus 5 hyperbolic sine x. So let me show you how to work out the range. So this is a continuation of the last example. So in the previous video I showed you how to write 13 hyperbolic cos x plus 5 hyperbolic sine x in this particular form, and in the previous video I showed you a method which I explained in steps. So there were 5 steps in total to find r and alpha. Okay, so we came up to here in the previous video. So in order to find the range of this expression, we're going to use the answer that we had here in the previous video. Okay, so remember, 13 hyperbolic cos x plus 5 hyperbolic sine x. So in the previous video we wrote it in this particular form. Okay, so these two expressions are equal. So we had 12 hyperbolic cos x plus ln 3/2. So what I'm going to do is, if I show you a method to find the range of this expression on the right, that's the same as finding the range of this expression on the left, as these two expressions are equal to one another. Okay, so to find the range of this expression on the right, step number 1 is first write down the range of y is equal to hyperbolic cos. Okay, so first start with hyperbolic cos x. since we have a hyperbolic cos term over here. Okay, so whatever function you have here, okay, first give the range of that function firstly. So the range of hyperbolic cos x is greater than or equal to 1. Okay, so it's cos x greater than or equal to 1. That is the range of hyperbolic cos x. In step number 2, so continue to the next step. Now write down the range of hyperbolic cos x plus ln 3 over 2. So in step number 2, write down the range of y is equal to hyperbolic cos x plus ln 3 over 2. So this is just a horizontal translation. So the plus ln 3 over 2 is a horizontal translation, so it wouldn't affect the one on the right hand side here. So the range would be hyperbolic cos x plus ln 3 over 2, that is greater than or equal to 1. So remember, it's a horizontal translation, okay? So that wouldn't affect the 1 over here, okay? In step number 3, now using this inequality in step 2, write down the range of 12 hyperbolic cos x plus ln 3 over 2. So therefore the range of y is equal to 12 hyperbolic cos x plus ln 3 over 2. So to get that range, all you do is multiply this inequality throughout by 12, which is r. Okay, so if I multiply by 12, so if you multiply by r, the inequality in step number 2 throughout, you're going to have 12 hyperbolic cos x plus ln 3 over 2, and that's greater than or equal to 1 times 12, which is 12. Okay, so there you have it. So there's 3 steps involved, okay, and that is the method in order to find the range of expressions such as these. Okay, now I'm going to continue further, so let me continue on the reverse, and I'll call this part C. And what I'm going to do now is I'm going to show you how to sketch. So if I take where this question started, so I'm going to show you how to sketch y equals 13 hyperbolic cos x plus 5 hyperbolic sin x. So let me show you how to sketch y equals 13 hyperbolic cos x plus 5 hyperbolic sin x. So in part C, sketch y is equal to, okay, 13 hyperbolic cos x plus, okay, 5 hyperbolic sin x. So let me show you how to sketch this. So in the video prior to the previous video, we went through how to write 13 hyperbolic cos x plus 5 hyperbolic sin x in the form r hyperbolic cos x plus alpha. So we did that particular part, and we found that r was 12, alpha was ln 3 over 2. So I'm going to use this answer in order to help me with the sketch in part C. So remember, 13 hyperbolic cos x plus 5 hyperbolic sin x. In part A, we wrote it as 12 hyperbolic cos x plus ln 3 over 2. So let me use, therefore, this term to help me with the sketch, so the term on the right hand side. So to sketch this, so let me grab a pencil, hope this works. So if this is my x and y axis, and this is the origin, okay? Remember the sketch of hyperbolic cos x. Hyperbolic cos x is a curve of this form, which crosses the y-axis at 0 and 1, okay? And first of all, remember, the plus ln 3/2 is a horizontal shift, and plus means a movement to the left-hand side, okay? So this plus means a movement to the left-hand side, so it's a horizontal shift to the left by ln 3/2 units, okay? So since this is a shift, this is going to be minus ln 3/2 as we're going to the left hand, we're going to the negative part of the x-axis, so we're going to move into the left, remember, since we have a plus here. And now that means that the x coordinate of the minimum point will be minus ln 3/2, and the 12 means that the y coordinate of the minimum point will be 12. Okay, so it's a sketch, so your sketch is going to be better than mine, but the coordinate of the minimum point will now be minus ln 3/2, and the 12 relates to the y coordinate of that minimum point. So that's what that 12 over here relates to. Okay, so in other words, that's what the r relates to when it comes to the sketch. So that if you sketch the curve, you should have a curve of this form. Okay, so that is how you would sketch the curve. But also, if you want to work out the point where it crosses the y-axis, so remember, when the curve crosses the y-axis, the x value is 0. So let's work that out also. So I hope you can see that. So when the curve crosses the y-axis, the x value is 0, so the x coordinate is 0 when the curve crosses the y-axis. So I'm going to put x equals 0, so you can put it into here or here, they're both the same anyway, okay? So in this case, when I substitute x equals 0, let me substitute into here, we're going to have y is equal to 13 hyperbolic cos x, which is 0, plus 5 hyperbolic sine, so 5 hyperbolic sine x, which is 0, okay? So you can calculate that value, so you can use the definitions of hyperbolic cos or hyperbolic sine, but also you can do this quickly with the aid of your calculators, okay? So remember, there's a HYP button, so this is a Casio calculator, so in the Casio models, there is a HYP button, so let me show you, which when you press it, it gives you a library of hyperbolic functions, okay? So if you type in 13 hyperbolic cos 0 plus 5 hyperbolic sine 0, you should have a value of 13, okay? So the crossing point on the y-axis is the x value, so the x coordinate is 0, the y coordinate being 13, okay? So that is the method in order to do the sketch, okay? And that completes this video. So I hope you found this video helpful, and I hope to see you in the next video. Thank you.